Hi everybody, welcome to my walkthrough on the web challenges of PicoCTF 2025. In this video, I will be solving all the questions except for Pachinko, Secure Email Service and Pachinko Revisited. So without further ado, let's get right into the first question. So let's start an instance and then see what we can get. So I made a cool website where you can announce whatever you want. Try it out. So let's copy this link and open it in Kali Linux. Okay, so let's just try something basic. If I just hit hi in here, it's gonna make it bigger. So since the question says SSTI1, of course our primary objective is to try the heuristic payload to check if SSTI exists, which is this right here, or if this were timely for something in Java, you would do either this or this or this. Okay, so for the time being, we are just checking standard Python. So let's just check this out. 49. Great. So we have code execution. Let us try and so now that we have SSTI, let's check if we have any code execution. So I'm going to use a standard payload here. I'm going to do this, hit enter. So you can see that our server errored out. So this payload doesn't exactly work. So let's try a couple of others. Now a good place you can get payloads from is obviously Hacktricks. So we'll head to Hacktricks. And let's go to Jinja 2 because we figured out that is it. And you can see we have a request object in Flask. So let me just search for request. Yeah, so we will just make use of this one right here. Okay, we'll make use of this one right here. Copy, and we'll change a couple of things. So we'll do now the command we are looking for is definitely not this, so we don't even require this one, just this one. And so let's just go back and delete this entire thing because I'm not looking to run such a huge payload. So let's get rid of it and then just try ls. Okay, so we'll just copy this down and paste it here, then hit enter. And you can see we have this, and you can see there's a flagged file here. So obviously the thing to do is just cat flag, right? Cat flag and hit enter, and there you go. We can copy this and submit our flag down here. There you go. Now, since we have solved this, I will go for SSTI2 as well, since we just need to use the same payload, but now we've got a huge blacklist. So for SSTI2, we have essentially the same website and to a certain degree the same payload as well. Okay, and you will see what has changed. Wow, okay, it didn't even change. So as you can see, this payload works, but if you try a couple of the other payloads here on Hacktricks, you will see that a lot of these are blacklisted. Okay, so for example, OS is blacklisted, rather import is blacklisted, and so on and so forth. So how are we to bypass that blacklist? It's like this. And even then, if I'm gonna type cat flag, I think it won't allow it through. Cat flag, Oh wow, it's literally the same payload. So go ahead and submit this, and there you go. You bypassed it. So the next question we are going to look at is no sanity 1. So let's just read the description. A developer has added a profile picture upload functionality, however, it's flawed and it's an opportunity. Your mission, should you choose to accept it, Mission Impossible reference, is to navigate the provided web page and locate the file upload area. Your ultimate goal is to find the hidden flag located in /root. Additional details, yeah, it's the same stuff. So once our instance has started, now here's the thing, whenever hints are provided, access them. These things are free, bro. So it says file upload is not sanitized, and whenever you get a shell on a remote machine, check sudo-l. So obviously our objective is to get some sort of shell. So let's do ourselves a favor, copy it over and paste. And you can see that we can just upload a profile. Just for the lols, let's actually get an image. Once we have downloaded our image, let's upload one and upload profile, and we have a path, so let's check the path. Okay, beautiful. So we have a couple of things. One is upload.php, which means we need to get our hands on a shell. Yeah, now one approach that you can do is try and get a reverse shell, but that would require you to start a netcat server here like this, and then parallelly also have an ngrok TCP server like this. But for the time being, I'm going to show you a slightly better method, one that I actually like a little bit more. So what we'll do is I'm going to show you this tool, this right here, a single file PHP shell. All we are going to do is copy and paste this code. And please star this. This is a really cool shell. So let me show you how. All we'll do is copy this, paste it here, and try and upload our file. Since that wasn't the point. Yeah. And let's upload. So it did upload to uploads shell.php. So let's head there. And you can see we have a shell and we can enter commands and stuff. That's great. So we'll check this. So our second hint was to check sudo-l. So let's try that as well. Yeah. So now to become root, if you had a reverse shell, you would do sudo su like this, but we can't do that here because we don't have a TTY. So instead, what I will do is I will just execute whatever commands we need as root. So we need to get, we can list out whatever is in the root like this, and you can see we have it right there. So let's just get root flag.text. And there you have it. We have our flag. So let's just copy this and paste it down here. And voila, we have solved no sanity 1. The next question we have is head dump. So let's launch an instance. Welcome to this challenge. In this challenge, you will explore a web application and find an endpoint that exposes a file containing the hidden flag. About API documentation. Find the endpoint that generates files holding the flag's memory, whereas files holding the server's memory, where a secret flag is hidden. Start running PicoCTF news. Let's go and see what's in here. And you can see it's a news site, actually pretty well made. So we have this API documentation. Again, our Swagger UI. There's a heap dump. So let's just download this file. And so we really just need to search for the flag, cat, heap dump, grep, and you can see a bunch of these things here. There you go. The flag is right here. So again, very beginner oriented challenge. Quite easily we can solve this. Next one, Cookie Monster secret recipe. Cookie Monster has hidden his top secret cookie recipe somewhere on this website. As an aspiring cookie detective, your mission is to uncover this delectable secret. Can you outsmart the Cookie Monster and find the recipe? We checked all parts of the web page. Cookies aren't. Let's open this up here. First of all, let's clean all of this out. Okay. So the next question is Cookie Monster's secret recipe. So let's just try something. Access denied. Me no need password. Me just need cookies. And have you checked your cookies lately? I'll just check it here. No cookie. I mean, there is something here, but oh wow, okay. Bruh, that is the most lame flag I've seen yet. So there you go. You solved Cookie Monster's secret recipe. So all we had to do was analyze the request here, and there was this base 64 encoded string, which if you check it out in Burp Suite, will automatically be decoded for you as your cookie. Otherwise, you can use any other method as well, right? So if you found this cookie through the dev tools of the browser, you could do something like and this will work as well. So the next question we have is eval. So this is a little tricky question, and so let's get right into it. So we'll just get right into it. Hey, that's weird. There we are. Okay, so enter the formula. Example PRT into rate into times 1000 times 23 times 32, I guess. Okay, nice. So it's just standard stuff. So I'll get right into the exploit. So and the thing is, it evaluates pretty much anything. Okay. So what we're gonna do is something like this. So we'll do now. You will see that this will actually execute. So how are we to do this? So one thing you can do is import. Now you can do you can see our table here, right? Our hex character table. So we can just find small o over here, lowercase o. So o is so you can see that even double quotes are blacklisted. So we will try this a little bit differently. Import, and we'll actually build the string dynamically. So how do you do this? You can do So we can do it like this: chr111 plus chr, let's find as 115 dot and then now let's actually build the entire thing. So here for now we'll just do ls. So chr 108 plus chr s is again 115 dot read. We'll try this, and as you can see we have code execution. So now what do we read exactly? We'll build this payload out here again. So now we need to find flag. Let's see where flag is hidden. So now because I've already solved this challenge, I know that flag.txt is located in slash. Okay, and so the final payload will be, so that payload looks like this. So this is our entire payload. Obviously I'll paste it down here and URL encode all the necessary stuff, and you can see we have our flag. Again, if you want, I will link this down in the description so you guys can check out how you can build it. Okay, so for this video we have two more questions left, that is WebSockFish and Apriti Sesamo. Let's get right into WebSockFish. Now I'll be real with you, this was probably the most irritating challenge that I had that was there in this CTF, because of the way that this stupid fish just trash talks. But I'll show you how. So here I'm just gonna perform a fool's mate just so that you guys can see the requests and everything. Okay, so the fool's mate goes like this: 1 2 3, there you go. So that's it, that's checkmate. But you can see that we have not actually lost. Okay, so and you can see that a lot of requests are being made from the WebSocket, and let's just see what it is. Now the hint that we are given is to understand the code and see how the WebSocket client is interacting with the server. So we will do just that. Alright, so we'll just go to the standard HTTP history, and when you go here you will see a lot of code. Okay, I'll send this to the repeater and I will show you. Hey, what? Why is this cookie still set? This cookie is from the secret recipe question. Don't worry about it. It plays no role here. So the important part, you can check out all of the code. The important part is actually this right here. Okay, so you can see that it's actually reacting based on what eval message is being sent. So you can see that there's a message event which updates the chat, which is this right here, and then we have a send message which sends the message to the WebSocket, and we have an update chat which gets that message from the WebSocket and then updates it out. So let's see what it is sending. You can see that it sends us, it just sends the state of the game. So now a little bit of chess engine knowledge. This I found by a lot of googling, but I'll tell you. So when it says eval 40, black has a slight advantage. So see, I'll just send this to a repeater, and now what you need to know is a standard eval value would be somewhere between minus 520 to plus 520. So this is somewhere where the standard eval value lies. But we can, the way to solve this question, I sent it the most random eval value possible, and it will just give you the answer and give you the flag. So we have the next question which says that which states that there is a web app here which claims to be impossible to hack. However, it's not for us, as you will see. So it says backup files, and to rumor has it that the lead developer is a militant Emacs user. So the first thing that you can see is that it's a simple website, and you can hit the login button, and we have some logging in here. So let's just try some basic credentials, and it says failed, no flag for you. And you can also see that there's not a lot of, yeah, this is a little better for me, and you can see that there's not a lot of info as well. So you can fuzz around the website, and I already tried, and there is actually nothing on this website except for this login page by the looks of it. So how do we do this? So this is where the hints play a role, and the second hint here especially. It says backup files, right? And it says militant Emacs user. So what we need to do is try and find an Emacs backup file. Now I don't really use Emacs, so I did not know how this is. So instead I just checked. And you can see this. So this is the page that I used to find it. So you can see that it just adds a tilde after the name of the file. So let's try that out. So let's add a tilde. So we did get somewhere, and you will see the difference is that we have this bit of code here. Okay, and so this is what the PHP file decodes to. Okay, obviously the variables are like this, but that's fine, right? So so how do we do it based on this? So let's see what's going on here. And what you can see is that it checks if the username and password are the same, and if it is the same, it says failed, not valid. But if the SHA-1 username is equal to the SHA-1 of the password, it will give us the contents of the file. Okay, so that's fair enough. So the question, so obviously what we are looking for here is some way to fool the thing into thinking that we can get. So we essentially need to enter a username and a password that is different, but get the same SHA-1 hash. And the thing is, you kind of can't. Okay, not by any way. Now you'd be tempted to think that this line here, right? This line here means you can try and do some type juggling. Yes, you could try, but for all the attempts I made, it didn't work. So the solution to this is to use something called the shattered exploit. So let's just Google that around. So the shattered exploit is this. So what this means, what this is essentially that Google managed to produce two PDF files, okay, PDF1 and PDF2. So what happened is that PDF1 and PDF2, both of these are different, as you can notice, but they produce the same SHA-1 hash. So what do? We'll write a simple script that sends this exploit down to impossible login.php. Okay, so I just got the script. I'll share the guy who I got it from online. Just give me a sec. Let me do a little bit of this thing. And now let us properly run it. Python main.py. And then let's paste this in here. And it will print out a response, right? It got this, and yeah, all right. So let's just post that in here. And we should get the flag. So we exploit a hash collision to get our hands on the flag. And that is it for this volume of PicoCTF. So until then, be sure to share, like, and subscribe. We will meet again in the next video. Bye bye.